Okay, let's talk about gravity and friction in the same video here. And let me start this. So if you'll notice here, this small ball is moving faster down um, compared to the large ball. And gravity doesn't work that way. It is actually related to the mass of an object. So they should fall at the same rate. All of these should fall at the same rate. And the way that we can affect that is by relating our force to our mover mass before we apply it. So here we're going to do this with gravity, and then we're also going to do this with friction. Um, and these are, I'm going to talk, they're kind of, what we're going to do is the same in both, is we're going to do something above to affect the value that we pass in, and what we do above is going to be, we're going to be using values off of our mover for this instance. And so with gravity, we're going to do G equals rs dot vector scale, and we're going to do gravity, and we're going to do m mass. So before we apply the force to this m, that force is going to be based off of its mass. So yeah, so I'll show you what that looks like here. Yeah, let's try it. Oh, I wanted to bump this up before I did it. Let's do 7. Okay, so you can see that I had that hashed out, so it was doing like we said before, where this was falling faster than our ball here. So let's see if this changed it, if we put that line of code in. Oops. G. And instead of gravity, we're going to be putting G in. And then also, let's take out our print time list. We don't need that. So let's try this. Yeah, so you can see that they all fell at the same rate. So that's gets us more accurately represents gravity, but we're leaving a lot out. But like I said, this video will just show us how we can, you know, fashion our forces off of the properties of the mover. So let's do the same with friction. And friction is equal to -1 times unit v, and that's velocity, and times mu, that's the strength, and then by the normal. And you want to look at the picture that Daniel Schiffman uses for this if you're interested in it. If not, then that's okay. So let's take out both of these in one line of code, and the way we're going to do that is we're going to rs vector unitize, and we're going to unitize this mover's velocity. And once we have that, once we have the unit, we're going to pass that into rs dot vector reverse. And we're going to call that v. So whenever you see something a long line like this, you always just want to think about it from the inside out. So, okay, we're starting with a velocity, our velocity vector for this mover. We're unitizing that, so now it has a length of 1, and then now we're reversing it. So it's the same thing as multiplying it by -1. So we have this right here in this line, and so now we need to, our mu and our normal, we're just doing the simple version of this, and so we're using the normal. We're just going to have it be 1, and then for mu, the strength, let's also put that as 1, and if it does anything weird or we need to change these later, we will. So okay, so now that we have those two, we are going to get our friction, and the way that we're going to do that is we're going to take this velocity and scale it by this magnitude, these two. So we'll multiply these together and use that to scale this. So rs vector scale, and we're going to pass in v, and we are going to scale by mu times normal. Now you'll notice that we have 1 and 1 here, so we really don't need this line of code, but if we want to affect these variables in the future, it's just easier to put them in now. So let's test this. It could not convert none to a vector 3D. Line 84. So if this is 0, 0, 0, then it can't do any of this code. So we are going to say if not rs dot is vector 0, and we're going to pass in m velocity. So we're saying is vector 0. If it is vector, so this returns a Boolean, and so if it's vector 0, we don't want to do this. And if we don't apply this force, then we just don't apply this force. It doesn't really matter. Okay, so let's see if that worked. Yeah, so you can see that the bouncing balls, they settle. Yeah, so there they are. We have settled. Whereas, let's just look at it again and not apply the force. And so if we do this, it won't settle. Yeah, see there, they keep going. And I guess it kind of does settle. But anyways, it was already settled by this time before. So So let's bring that up and look at it, watch it once more, and then end our video. Okay, and like I said, the point of this video is just kind of to show you that we can do something with the force that we want before we pass it in. So we can refer to the mass or the velocity of our mover before we apply it. So it's like making a custom force for each mover. There, we're pretty much settled by 200.